let's go. Ooh, I think I trimmed these down because I had some confusing ones. Newton meter. Oh no, it's all right. Newton meter. That's measurement of torque. Yeah. Energy and work are not too far off because that's how we calculate it. We do newtons times meters, but I hope this is updated. I got rid of a couple that were outdated. Okay, a foot pound is actually how we measure energy and work. Don't worry, I will not try and confuse you on a test with this, but a foot pound is actually how we measure work or energy. And then a pound foot would be how we measure, if it's not energy and work, what are we measuring with a pound foot? That was the other way. And again, I will never ever try and confuse you on a test or in the classroom with this, in the shop with this, but a pound foot is technically not energy and work. It is, what's that, folks? Torque. Torque. What do we need to make power? What do we need to make it power? Foot pound is not equal to pound foot, correct. Foot pound is torque. Foot pound is work. Pound foot is torque. And I will never try and confuse you with that, but I would like you to see the difference. Yeah, that's not confusing at all. You need to add time, Braden. Thank you. It's not about how much work you did. It's about how fast you did the work when we talk about power. Well, you know that I ride an FJR, and you know that Mr. Cliff rides a Ducati. You didn't know perhaps that Mr. Gunn rides a BMW. No, it's not, but there seemed to be a disproportionate number of motorcycle riders. And then there's, oh gosh, his name is another, we got another instructor, he rides as well. There's at least 2 other motorcycle riders on our staff. Okay, this will be on the test. This first one that really will be on the test. There are test questions that are very much like this. Ooh, not many students got it. Okay, when you want to convert RPM and torque to power, what do you need to do? Multiply them together and then divide by a constant. I don't care what the constant is. What is 2400 times 200? Well, 24 times 2 is 48, and there's going to be 4 zeros. Thank you, Huey Gone. What is 16 times 3? 48. So 48, 480,000 is kind of the base number for the first engine, and 480,000 is my beginning number for the second one. So the power stayed the same. Does that make sense? There are test questions that are very much like this. Tells you that the RPM and the torque change, it tells you how they change, and then it asks you to interpret. Okay, well, let's try another. Yeah, all you got to do is compare. I'm not going to ask you how many horsepower. I just want you to tell me which one was bigger. Nice. Most people got it this time. 1,800 times 3, 48, same number. Little bit of math, not too hard, I hope. And then 15 times 4 pushes us up to 60. So this engine's bogging down, but the power is increasing because we just kept pouring the coals to it. We're now climbing. As opposed to we were flying level in the first one. The second one, we're probably climbing. We're accelerating. All right. Still lost a few of you. Is there anybody that needs some help with this? 18 times 3 is 48. 15 times 4 is 60. Can I compare with the torque only? No, because you need torque and RPM to know your power. Power is a function of how hard you pushed and how fast you pushed. Why would you say there's not enough information there, Sean? I've given you torque and I've given you RPM. Yeah. For what Sato said, Sean. Oh, I see. I see. Okay. Yeah. Yeah. Torque times RPM is how we calculate power. And I think there's another one. Okay. So what if we gave There are questions like this on the test. Okay, so how much work did Alex do? And I don't care foot pounds, pound feet. Just tell me the number. 40 in 10 seconds. All right, he did 40 in 10 seconds. How much did Sue do? 20. And how long did she take to do 20? In 5. So if Alex did 40 in 10 and Alex did 20 in 5, we can see that Alex did more work. Anybody? 40 is bigger than 20. Alex did twice as much work and he took twice as long. So is it task failed successfully? All right. Does anybody want me to kind of go over this again? Or is this starting to click? Yes, go over it again? Or yes, it's starting to click? Yes, go over it again. Okay. Work is force times distance. The force for Alex is 10, and the force for Sue is 5. The distance for Alex is 4, and the distance for Sue is also 4. So Alex lifted a 10-pound weight. He lifted it 4 feet off the ground. Sue lifted a smaller weight. She also lifted it 4 feet off the ground. So they each did some work. How do we describe that work? We say how much weight multiplied by how far. What if Alex picked up a bigger weight? If he picked up a bigger weight and carried it the same distance, he would have done more work. In this case, Sue picked up a smaller weight. She picked up a 5-pound weight, while Alex picked up a 10-pound weight. They both lifted it 4 feet. So Alex picked up a bigger weight. He lifted it 4 feet. Sue picked up a smaller weight. We can describe how much work they did by multiplying the force times the distance. In Alex's case, 10 times 4 equals 40. In Sue's case, 5 times 4 equals 20. Okay, Yedo, do you understand how to calculate how much work they did? Got it? Okay. Now, do you understand why they were both the same amount of power? Okay, then I'm going to move along. Brake horsepower plus friction horsepower would give us a nice number. When an engine is idling at 700 RPM, how much brake horsepower is it putting out? Your engine is idling, just sitting there spinning, not connected to a transmission, just sitting there spinning. How much brake horsepower is it putting out? 0, right? But it is going through a significant amount of friction horsepower, right? Because if you were to try and spin the engine at 700 RPM with your arm would get tired because we're using friction horsepower. What if we're sitting at that same 700 RPM, but we now put the car in gear and start cruising along, slowly climbing a hill? My friction horsepower won't change. It's still 700 RPM, but my brake horsepower will increase. I'm now making useful power. When we measure how much horsepower an engine can make, we really don't care how much friction is inside the engine from how the aircraft performs. We care about how much brake horsepower could be considered the same as propeller horsepower. In our case, the propeller is basically the brake, the source of load to the engine. So if it helps you to understand it, consider brake horsepower to be propeller horsepower, prop shaft horsepower. Don't know what else to say. I can just sort of state the fact here. Time, very good. Work to time. Distance is work, force, and distance. Okay, that's it. Let's see what folks did.